Hi everyone. So today we will study about intermediates and our first intermediate is carbocation which is a carbon intermediate. So let's go back to study. So here carbon, we know that carbon has four valencies, but here only three bonds are formed. We know that carbon is tetravalent, but here only three bonds are formed. Here one positive charge, so this is called carbocation. Okay, because three valencies are complete and one is missing, and we have positive charge. The carbon is here is sp2 hybridized, so we can calculate that the number of sigma bonds, the hybridization is equal to the number of sigma bonds. So sp2 hybridization and we have three sigma bonds. Okay, and the structure of this carbocation is trigonal planar, formed by heterolytic cleavage. So its structure is trigonal planar because this is a triangle. We know that one from this r and this r, here is a triangle, so it is triangle and it is planar, so it is called trigonal planar. Okay, since carbocation is trigonal planar in shape, so it does not form at bridgehead position. So here this is a non-planar compound, and we know that carbocation is planar, so it cannot be formed here. So this is not formed here. So this is the region, and it is non-planar. It is also non-planar, so it can be formed here. Okay, but as well as size of bridgehead increases, almost planarity at bridgehead position arises and stability of carbocation increases. So if this size, this is the bridgehead of, if this size increases, and then stability of carbocation increases. So here the most stable bridgehead position, and here is the least stable, because this is planar, this carbocation becomes planar because of the size of bridgehead position. So here least size and here most. So this is the stability order of carbocation on bridgehead positions. Next, we will study about method of preparation of carbocation. So, what is the methods of to prepare carbocation? How we prepare carbocation? So, let's start the first process of method. So, first process is from alkene. We know that alkene is a hydrocarbon. So, here we have alkene present, carbon double bond carbon. So here what happens in the presence of H plus, here is the some bases which, sorry, acids which give H plus. So what happens here, this bond migrates here, and what in the presence of H plus, this double bond migrates here, and here comes positive charge, which means carbocation. Carbon has three bonds, 1 2 and 3, and this positive charge, so here arises carbocation. So here what happens here, and in the presence of acid we have this H plus, this negative charge here becomes negative charge, take the H plus, and it becomes this. So this is the carbocation we have prepared. So this is the first process. Now some examples of this carbocation. So we have this double bond, it migrates here from here to this carbon, and this is the perbenzoic acid. In the presence of perbenzoic acid, we it gives us H plus ion, and here negative charge arises. This negative charge take the H plus from this acid, and here we have positive charge arises, so we have found the carbocation. So one condition is pi electrons shift, here more stable carbocation formed. So this carbocation only shift on the on this side, that side position, we have got the most stable carbocation. This double bond do not shift here, because we have found here least stable carbocation, and we have found here most stable carbocation. So next, this carbocation, sorry, this double bond shift here, and we have here positive charge, here negative, and this acid give H plus ions. So we have the product, and this is the carbocation. This is most stable carbocation we get. So next, here what happens, this lone pair, it is it is it is in conjugation with this double bond. So here this lone pair migrate here, and this double bond migrate here. So we have, what happens here, we have get the carbocation. So this is called substituted carbocation. Second process is from alkyl halide. So we, what happens here, this single bond migrate to here because it is more electronegative. So we have halogen and alkyl group. So this is in the presence of heat, polar protic solvent, we have get the this carbocation, and this is halogen. This is the some examples of this. Next, from alcohol. So what happens, case first, in the presence of acidic medium H plus, what happens, this H plus attacks on this OH, and we got OH2, sorry, H plus 2 not attacks on this lone pair of oxygen, attacks on H plus, sorry, this lone pair attacks on H plus, and we got OH2 plus. So this is the product we got. Then this OH2 plus removes, and we got, in the presence of heat, this removes, and we got R plus. R plus is a carbocation, and H2O. So this is the product. Second case, this is alcohol, and we have Lewis acid. So what happens here, this lone pair attacks on this acid, and we got oxygen, BF3 negative, and H. So here good living group, it is it becomes good living group, and then this group, this complete group is good living group, and we got it carbocation. Okay, next is from epoxide. So what happens here, this oxygen attacks on this H plus, and it is attached to oxygen. So this, we got positive charge on oxygen. So from here, this bond will break, and here it is shifted. So we got OH and single bond, and this here we got positive charge. Second case, same Lewis acid, it got here BF3, and we got this compound plus and this negative. Now this bond will break and shift it to here, and this is the product, final product we got here. This is the carbocation. Next is from acid halide. So here, this is the leaving group, it removes from the compound, and in the presence of AlCl3, so it becomes AlCl4, and but this is the compound we got, this is carbocation. Psyllium ion. Next, it is very important example of carbocation. So here we have leaving group Cl, AlCl4, it becomes AlCl4, and it here carbon has positive charge, so it is the intermediate we got. Next, in the presence of heat, this CO removes from the compound, and we got this carbocation, tertiary butyl carbocation. So this is the important example of preparation of carbocation. Next we found the stability of carbocation. So carbocation, aromatic carbocation is more stable than non-aromatic and then anti-aromatic. Resonance is more stable hyperconjugation than inductive effect. This is the overall stability of carbocation. So firstly we got most stable is aromatic carbocation. So here this is 2 pi electrons and 2 4 6. So this is most stable because least size carbocation is more stable than the large size carbocation. Okay. Second, miscellaneous carbocation. Here miscellaneous carbocation means we have this compound, it is called miscellaneous plus ch2. So substituting, third पे substituted carbocation. So here it is substituted because oxygen is attached to this, here nitrogen is attached to this. Substituted means any heteroatom is directly attached to carbocation. Then fourth, resonance carbocation is more stable. Here what happens, this is more stable and then this carbocation. Hyperconjugation, here number of alpha hydrogen, greater the number of alpha hydrogen, greater the stability of carbocation. Here 3 alpha hydrogen, here 3 6 alpha hydrogen, it is more stable. So next, inductive effect. Higher the inductive effect, higher the stability of carbocation. Plus I, higher the plus I, higher the stability, sorry, no plus I, higher the minus I, higher the stability of carbocation. Percentage S character. So higher the percentage S character. So here first is more stable, then third and then second. Sorry, इसमें क्या होगा, sorry. So this is the percentage S character. Then last is anti-aromatic. So this is the series of stability of carbocation. We will study it in detail. Okay, so this is the overall stability of carbocation. Next video will be on reactions on of carbocation. It will be on in next video. Thank you for your time and response.